In this video we show how to create a 3-degree bevel like you might do on the edge of a door, and we'll use a variable for that angle so we could really make that 3-degree bevel just about any angle we wanted to. And be sure to watch the first video on creating fictitious faces before you watch this one if you're not familiar with how to create a fictitious face. So and let's also, on our dimensions that we have here, they're 84 by 5.5 by 1 3/4. Let's make those a little smaller so that the scale is smaller and it's easier to see what it is we're creating. In the end, what we're going to create is parametric, so we can change and make those length, width, and thickness values anything we want when we're finished. So let's start off by creating a variable that we'll use to control how far we tilt our beveled edge from vertical. We have to know what that value is and be able to calculate it based on some bevel angle. So let's start off and set the variable R0 to be 3, and let's let that be our bevel angle. And then we have to create a formula that calculates how far we tilt our beveled face or our fictitious face from vertical. So that formula takes the thickness of the part, or which we use the parametric value S, and we'll multiply that times the tangent of our tilt angle, which in this case is 3, and we've defined that to be the variable R0. So we put the variable R0 inside square brackets, so our formula is thickness times the tangent R0, and based on a thickness of 1 3/4, that distance calculates to be about 0.09 inches that we tilt our face from vertical. So we want to remember the variable R0, and that's what we'll use in our formula in our fictitious face. So let's go over and create the face, and we're going to create this beveled edge on this front edge of the part, so we'll be tilted back from vertical about here where you see the mouse. So we'll go to fictitious faces, and we'll go to the first available face, and we'll call it 3-degree front for the front edge of the part. And the 3 points we need to define, P0, P1, and P2. Of course, we have to do set X, Y, and Z coordinates for each. P0 is the bottom left corner of the part, so that's all 3 values are 0. And P1 for the X value is, we use the parametric value L for the length of the part. Y and Z are both 0. And then back to P2, which is on this end of the part, and this is where we define the angle that we tilt our face. So our X value is still 0, but then our Y value is R1, which we set up earlier, and that's the distance from vertical that we tilt the face. And P2 and Z is the thickness of the part. We use the variable S for that. So now that we've set that, now we have our face that's tilted. Let's go look at this in the 3-degree view. That's easier to see there. So here we are in the 3-degree view. If we rotate our part around, then we'll be able to see the blue line is the face that we've created, and you can see that it's tilted back slightly from vertical. And we can of course make that angle, because we used a variable for that. We could make that really any angle we wanted to. There's a 45-degree tilt. And the nice thing with Genesis Evolution is that when you program this fictitious face, all the calculations that the machine needs to move and approach and machine on this face perpendicular are handled by the angle of this face automatically. So we could even take machining that we've done on another face that's not angled and copy it to this new fictitious face. And to illustrate this, let's take one of these faces, nominal faces on the right hand side, and let's do a mill setup, and let's put it in the middle of the length of that face, which is length of face divided by 2, in the middle of the height, which is height of face divided by 2, and let's make it 2 inches deep. And we'll go pick, let's use this aggregate for our tool. And so now we have a mill setup in this end of the part. Let's go to our 3-degree view and look at it on an isometric. So now you can see that mill setup that enters that part at 2 inches. But now let's go take that machining command and just copy it. and we'll copy it to the clipboard. I'm going to copy the whole thing. Now let's change our face to 3-degree front, and we're looking at that head on. We can turn off some of the other faces to make it a little less confusing, but we'll paste that command in, and now let's go back to our isometric view, and now we have that machining command on that face that's already at that angle. So the machine would know to come in and approach, drill in, and come out on that 45-degree angle. It is up to us to set that aggregate to that angle. Unless we had a 5-axis machine, that would actually tilt to that angle automatically. Or if we had the bends aggregate that can set its angle automatically at a setting station, then all that would happen automatically. If we have a manually set aggregate, then we have to set that angle automatically, but the machine would know to move in and out along that 45-degree angle, and that same bit of code that we use to control or to drill the hole on the edge of the door would also work on this face too. So that's one of the real powerful features of the fictitious face, is that you're not concerned about, once you define these angles, then you can really forget about them and work on this face as though it's one of the nominal faces on the part.